Binary compounds of silicon are binary chemical compounds containing silicon and one other chemical element. Technically, the term silicide is reserved for any compounds containing silicon bonded to a more electropositive element. Binary silicon compounds can be grouped into several classes. Salt-like silicides are formed with the electropositive S-block metals. Covalent silicides and silicon compounds occur with hydrogen and the elements in groups 10 to 17. Transition metals form metallic silicides with some exceptions, silver, gold and the group 12 elements. The general composition is manganese 4 silicide or MsIn with N ranging from 1 to 6. Examples are M5C, M3C, Cu, V, Cr, Mo, Minnesota, Fe, Pt, U, M2C, Zr, Hf, Ta, Ir, Ru, Rh, Co, Ni, Ce, M3C2, Hf, Th, U, Msi, T, Zr, Hf, Fe, Ce, Th, Cu, and Msi2, T, V, Nb, Ta, Cr, Mo, W, Re. The Kopp-Newman law applies as Cp m c equals xCp m plus yCp c. As a general rule, nonstoichiometry implies instability. These intermetallics are in general resistant to hydrolysis, brittle, and melt at a lower temperature than the corresponding carbides or borides. They are electrical conductors. However, some, such as CrSi2, magnesium silicide, beta-iron 8 silicide and manganese 4 silicide. 7, are semiconductors. Since degenerate semiconductors exhibit some metallic properties, such as luster and electrical conductivity which decreases with temperature, some silicides classified as metals may be semiconductors. Group 1 silicides of Group 1 elements are salt-like silicides, except for silane silicon hydride, whose bonds to hydrogen are covalent. Higher silane homologs are disilane and trisilane. Polysilicon hydride is a two-dimensional polymer network. For lithium silicide, many cluster compounds are known, for example lithium silicide, lithium silicide, lithium silicide and lithium silicide. Li 4.4C is prepared from silicon and lithium metal in high-energy ball mill process. Potential uses include electrodes in lithium batteries. Lithium silicide has a Zintal phase with planar C56- rings. Li NMR spectroscopy suggests these rings are aromatic. Other group 1 elements also form clusters. Sodium silicide can be represented by sodium silicide and sodium silicide, and potassium silicide by potassium silicide. Group 1 silicides are in general high melting, metallic gray, with moderate to poor electrical conductance and prepared by heating the elements. Superconducting properties have been reported for barium silicide. Several silicon Zintal ions C44-C94-, C52-, are known with Group 1 counter-ions. Group 2 silicides of Group 2 elements are also salt-like silicides except for beryllium, whose phase diagram with silicon is a simple eutectic 1085 degrees Celsius at 60% by weight silicon. Again, there is variation in composition. Magnesium silicide is represented by magnesium silicide, calcium silicide can be represented by calcium silicide, calcium silicide, calcium silicide, calcium silicide and by calcium silicide. Strontium silicide can be represented by senior 2C, SRSI2 and senior 5C3, and barium silicide can be represented by barium silicide, barium silicide, barium silicide and barium silicide. Magnesium silicide, and its solid solutions with Mg2J and Mg2Sn, are good thermoelectric materials and their figure of merit values are comparable with those of established materials. Transition metals. The transition metals form a wide range of silicon intermetallics with at least one binary crystalline phase. Some exceptions exist. Gold forms a eutectic at 363 degrees Celsius with 2.3% silicon by weight, 18% atom percent, without mutual solubility in the solid state. Silver forms another eutectic at 835 degrees Celsius with 11% silicon by weight, again with negligible mutual solid state solubility. In Group 12, all elements form a eutectic close to the metal melting point without mutual solid-state solubility. Zinc at 419 degrees Celsius and greater than 99 atom percent zinc, and cadmium at 320 degrees Celsius. Commercially relevant intermetallics are Group 6 molybdenum disilicide, a commercial ceramic mostly used as an heating element. Tungsten disilicide is also a commercially available ceramic with uses in microelectronics. Platinum silicide is a semiconductor material. Ferrosilicon is an iron alloy that also contains some calcium and aluminium. Manganese 4 silicide known as brownleeite can be found in outer space. Several Minnesota silicides form a Nowotny phase. Nanowires based on silicon and manganese are also known. They can be synthesized from Minnesota CO5 silicon chloride forming nanowired based on, or grown on a silicon surface. Manganese 4 silicide .73 was investigated as thermoelectric material and as an optoelectric thin film. Single crystal manganese 4 silicide .73 can form from a tin lead melt. In the frontiers of technological research, iron disilicide is becoming more and more relevant to optoelectronics, especially in its crystalline form beta iron 8 silicide. They are used as thin films or as nanoparticles, obtained by means of epitaxial growth on a silicon substrate. Group 13. In group 13, boron, a metalloid, forms several binary crystalline silicon boride compounds, silicon boride, SiBN. With aluminium, a post-transition metal, a eutectic is formed 577 degrees Celsius at 12.2 atom% Al, with maximum solubility of silicon in solid aluminium of 1.5%. Commercially relevant aluminium alloys containing silicon have at least element added. Gallium, also a post-transition metal, forms a eutectic at 29 degrees Celsius with 99.99% Ga without mutual solid-state solubility. Indium and thallium behave similarly. Group 14. Silicon carbide (SiC) is widely used as a ceramic or example in car brakes and bulletproof vests. It is also used in semiconductor electronics. It is manufactured from silicon dioxide and carbon in an Atchison furnace between 1600 and 2500 degrees Celsius. There are 250 known crystalline forms, with alpha silicon carbide the most common. Silicon itself is an important semiconductor material used in microchips. It is produced commercially from silica and carbon at 1900 degrees Celsius and crystallizes in a diamond cubic crystal structure. Germanium silicide forms a solid solution and is again a commercially used semiconductor material. The tin-silicon phase diagram is a eutectic and the lead-silicon phase diagram shows a monotectic transition and a small eutectic transition but no solid solubility. Group 15. Silicon nitride is a ceramic with many commercial high-temperature applications such as engine parts. It can be synthesized from the elements at temperatures between 1300 and 1400 degrees Celsius. 3 different crystallographic forms exist. Other binary silicon-nitrogen compounds have been proposed. SiN, silicon nitride, and other SiN compounds have been investigated at cryogenic temperatures. Silicon nitride, N22, SiNZ. Silicon tetraazide is an unstable compound that easily detonates. The phase diagram with phosphorus shows SiP and silicon phosphide. A reported silicon phosphide is silicon phosphide, no practical applications, formed by annealing an amorphous Cp alloy. The arsenic silicon phase diagram measured at 40 bar has 2 phases, silicon arsenide and silicon arsenide. The antimony silicon system comprises a single eutectic close to the melting point of Sb. The bismuth system is a monotectic. Group 16. In group 16, silicon dioxide is a very common compound that widely occurs as sand or quartz. Silicon oxide is tetrahedral with each silicon atom surrounded by 4 oxygen atoms. Numerous crystalline forms exist with the tetrahedra linked to form a polymeric chain. Examples are tridymite and cristobalite. A less common oxide is silicon monoxide that can be found in outer space. Unconfirmed reports exist for non-equilibrium silicon oxide, silicon oxide, silicon oxide, silicon oxide and silicon oxide. Silicon sulfide is also a chain compound. Cyclic silicon sulfide has been reported to exist in the gas phase. The phase diagram of silicon with selenium has 2 phases, silicon selenide and silicon selenide. Tellurium silicide is a semiconductor with formula Te2 or Te2C3. Group 17. Binary silicon compounds in group 17 are stable compounds ranging from gaseous silicon fluoride to the liquids silicon chloride and silicon bromide to the solid silicon iodide The molecular geometry in these compounds is tetrahedral and the bonding mode covalent. Other known stable fluorides in this group are silicon fluoride liquid, and polymeric solids known as polysilicon fluorides silicon fluoride X and SiF X. The other halides form similar binary silicon compounds. The periodic table of the binary silicon compounds. Greater than. References